जीनी, मेरी मुराद है कि मैं बन जाऊं एक शहजादा।
Of your car to start it. A small current from the battery flows through the starter solenoid. The solenoid gets magnetized and thus causes to close a pair of heavy contact and completes the circuit. As a result, a large current starts flowing through the starter motor, which sets the engine in motion. Thus, a solenoid is used as a starter in automobile engines. Do you know what a solenoid is? A solenoid is a long, insulated wire tightly wound in helical shape, such that its length is much greater than its radius. When a current passes through one end of the solenoid, a magnetic field is set up around the solenoid wire. As can be seen that when current passes through the solenoid, it attracts the iron pins. The current from one end of the solenoid wire whirls through each turn and eventually comes out through the other end. As a magnetic field is set up in the solenoid, its one end acts as the south pole and the other end acts as the north pole. The magnetic field outside the solenoid is very weaker and is close to zero. Inside the solenoid, however, the magnetic field is stronger and uniform. The magnetic field inside the solenoid is given as B is equal to mu naught Ni, where mu naught is the magnetic permeability of air, N is the number of turns per unit length of the solenoid, and I is the current flowing through the solenoid. If you switch off the current flowing through the solenoid, the iron nails stuck to it fall down. This is because the magnetism of a solenoid lasts till a current flows in the coil. As soon as the current stops flowing, its magnetism vanishes. AC generator. An AC generator is used to generate electricity at thermal power stations, nuclear power stations, hydroelectric power stations, and even at homes during power outages. Let us see how an AC generator produces electricity. An AC generator basically converts mechanical energy into electrical energy. It was designed by the famous physicist Nikola Tesla. The AC generator works on the principle of electromagnetic induction, according to which the change in flux linked to a coil induces an electric current in the coil. The direction of the induced current in the coil can be interpreted by using either Fleming's right-hand rule or Lenz's law. The setup of an AC generator consists of field magnets, an armature, 2 slip rings and 2 carbon brushes. The poles of field magnets are concave and cylindrical in shape, which produces a radial magnetic field. Armature is a soft iron core, on which a coil having a large number of turns of copper wire is wrapped. The 2 ends of armature are attached with 2 slip rings. These rings rotate with the coil. The slip rings are made of metals and the inner sides of the 2 rings are made insulated as they are connected to the axle used to rotate the coil. The external sides of the 2 rings are conducting as they pass the current to the external circuit with the help of the brushes. The 2 carbon brushes have one end each in contact with rotating slip rings and the other end is connected to an outer circuit. A galvanometer is connected in the outer circuit to show the deflection due to the current induced in the armature. When coil is rotated between the poles, a current is induced in the coil. Let's now see how it works. The armature keeps on changing its relative position with respect to the magnetic field as it rotates about an axis perpendicular to the field. Therefore, the flux linked with the coil keeps on changing with time. As a result, an EMF is induced. This in turn induces an electric current in the coil. As the two ends of armature are connected to an external circuit, an electric current starts flowing through it. This current is detected by the galvanometer connected in the external circuit. Due to change in relative position of the armature coil, the direction of current flowing in each arm of the armature coil keeps on changing, and hence the current so obtained is alternating current. To understand the generation of AC current through Fleming's right-hand rule, mark one arm of the armature as green and the other arm as pink. As per the Fleming's right-hand rule, the direction of current in the arm marked as green is outward and in the arm marked pink is inward. After rotating half turn in anti-clockwise direction, the direction of current in the green arm becomes inward and that in the pink arm becomes outward. Thus, after every half turn, the direction of current changes and as a result, alternating current is generated. If a graph is plotted between the induced EMF and time, then it will show the sinusoidal behavior of the induced EMF. The deflections of the needle of the galvanometer show that the direction of the current keeps on changing with time. Force. Magnetic field lines are useful for representing the direction and strength of the magnetic field. The field lines are continuous and endless, forming closed loops. Magnetic field lines are defined to start on the north pole of a magnet and end on the south pole. Inside the magnet, they appear to move from south pole to north pole. The magnetic field direction is the same direction a compass needle points. When the magnetic compass is allowed to move in a magnetic field, the needle always rests along the tangent to the curve. Carrying conductor. When an electric current is passed through a straight conductor, a magnetic field is produced around it. When we place a magnetic compass near to the current-carrying conductor, then the magnetic needle shows the direction of the magnetic lines of force. As the direction of the current is changed, the direction of magnetic lines of force also changes, which can be observed by the change in the direction of the needle of the magnetic compass.
We are very much familiar with electrical appliances like fan, heater, TV, etc.